Part of my screen. Okay. Good morning. I don't know if anyone's watching. I don't know what I'm doing, but I just kind of wanted to, I've been for the past couple months. I've been streaming in the morning on Twitch, and I had to stop for a while because my schedule got all back. But I'm back on a nice morning schedule now. I'm streaming again, rather than jumping right back into working on PayPres application tool. I wanted to take some time to think through some, well, basically an idea I've had for a long time. Kind of ties into like what I want to do. So I have an idea. I wanted to make a programming course that would start with. I guess the way I pictured it, it was start with like the idea of like what is a bit, work all the way up to building like your own little operating system, text editor, that kind of thing. Like a very minimal computing environment that would run on a virtual machine. That's one kind of on the practical side, and then on the other side, it's like, well, going all the way up to again, from bits all the way up to the idea of like the big ideas of P versus NP, big ideas in for the big questions. My wife wants me to videos on how do you write Python code, how do you, because where the well, I mean, I think that's where the market is, right? That people who are wanting to learn programming, they do the $ next to job descriptions and looking for Python and React and that kind of stuff. I'm more than happy to do something like that, but I want to. I don't know. I feel like a lot of people can do. A lot of people do that, and I have my own little take on programming. That's one reason I talk about J a lot. Is you know, my main programming language for many years was Python, and when I started Python, like nobody used it. Paul Graham, the guy that started Y Combinator or Hacker News and Y Combinator, he wrote this article called "The Python Paradox." It's all about even though nobody in the world, no companies in the world ever use Python, you should hire a Python programmer. A programmer that develops in Python, you should hire them because they're the kind of person that would go out and try something new. And be willing to do something other than just C script or JavaScript or C or Java or whatever the big name things were at the time. And it's funny at the end of that article at the very bottom. I'm probably pulled up. Yeah, at the bottom of that article, he talks about J as well. He mentions J in there. Well, I actually forgot it was Paul Graham for a while. I was talking about it to my boss. I work at a company that we use K, and I don't get paid to do J, but I similar language K. And it's an obscure language, but it's a really well designed language. I think it would be a lot more popular if it were open source, which I don't know why this image came up, but this is the background for my streaming channel, and this is a game I made in OK. Ike and OK are sides of the same coin. That they're a open source K implementation. My friend John Ernest made. He's super smart, and I made a video game in that for RA. Yeah, so I wanted to popularize OK. So this is one of two open source K implementations, like 3 open source. Actually, there's a bunch of open source K implementations. This is one of the 3 big ones. This one and NGN. Okay, never remember what it is. NGN is the initials of the author, Nick Anyway, but it's a very terse language, and it's really cool. And anyway, my new manager was talking about how hard it is to find K programmers, and uh, I kind of have a different take on that because I came to the company because it uses K, and uh, I think there's something similar there. So I'll bring it up to you. So I showed him this article, Python. Um, right, way back in August of 2004, and he's talking about um, that you could get smarter programmers to work on a Python project than you could to work on a Java project. And so I would say almost today I would almost say you could get smarter programmers to work on a K project than you could to work on a Python project. That's not that Python project programmers aren't smart, which is kind of the point of this is that right now Java is, or at the time of this writing, Java was the big thing. Everyone comes out of college learning Java, and everybody. Well, let's just read it. I don't mean the Java programmers are dumb. I mean the Python programmers are smart. That's exactly the thing, right? It's a lot of work to learn a new programming language, especially one that's not. At the time, I think there was like one Python book, mouse book, and then of course the docs. And it was Python today is a much more approachable language. Guido and whatnot, they did this programming for everybody or whatever. Standardize a lot of things, formatting of Python files. It's just a much more robust, approachable. There's a Python foundation now where make it work every day to make it easier to learn Python and to become part of the community. Which means that you get a lot of people who don't know what they're doing sucked in along with all the people that are really good and see it as a wonderful language. And Python is one of my favorite languages. I'm not in any way disparaging it. In fact, what I was saying is that I was one of the early adopters of Python as well, and I watched it turn from a extremely obscure language. Not obscure, but I mean, basically it had like a handful of users for 10 years, and then finally it started getting some popularity. Especially as the web came out. I don't know how. I don't know the timeline exactly, but I mean, it was definitely a very small world in 1.52, and I would use Python like at home, but like there was no thought of ever using Python on the job, and it was kind of a revelation to start seeing Python job pop up. Time. So I don't necessarily think that K and J are going to go through that kind of thing, but I think it's possible. They are good languages. So anyway, but there's something interesting about these languages in Python, compared to what was Perl was a big language then. I definitely moved for Perl, and Perl is a wonderful language as well. But there are some things that could be much improved, and so there was this whole thing to make Perl 6, and Perl that didn't go so well. So now there's many years later, there's this new language called Rakudo or Rako maybe, I don't know. I think one is the implementation one. Doesn't matter. Anyway, but Perl 6 became a completely different language. It's really nice, but it's at the time Perl was just probably one of the dominant languages in the world. Like everybody wrote Perl because that was the language of the web. And PHP came along, kind of ate into that. Python came along, kind of ate into that. Ruby came along, Ruby on Rails ate into that. You can still get a job writing Perl today, but it's I don't know. It's just not as predominant in the world. It seems to just, for whatever reason, it seems to be more of a backend kind of thing. Use it if you're a sysadmin or DevOps, that kind of thing. Anyway, I'm rambling, but the point is that these languages appeal to the kind of more obscure languages. Here's where Icon and Joy and Lisp, Smalltalk. Yeah, you know, they appeal to people who are kind of, you know, you kind of wonder why they're not more popular languages in the first place. Like, it certainly was crippled by the fact that it was, um, it's not open source. There are companies that use it and pay people a lot of money to write K. Um, I don't know. J, I don't know. You know, when I came to the 1010 where I work now, I worried that one of the questions I asked was like, how crazy is it to work on a code base where other people are writing K, you know, and it, you know, basically they said it's just not a big deal. It's just like any other language. Most of the time, when you're writing big like enterprise software, you know, you're definitely going to have like you definitely take advantage of the language, but there's you know it basically looks like a very compressed version of any other programming language. You've got a whole lot of extra power. It's condensed, uh, but it's just not hard. It's just the worries I had about, you know, oh, it's hard to read because it's unusual in curse and whatever, just isn't a big deal. And uh, you know, certainly trying to read other people's J code was intimidating to me in the past, but now it's not a big deal. I feel like somebody showed me their J code, I could probably go figure it out. You know, so it makes me wonder why aren't they more popular? And it's kind of a I think there's definitely a network effect. You know, if J is, and I'm not saying this is true, but say J is like X times better than Python or C sharp or whatever. Um, you know, you have to compensate for the fact that you as the founder of a company have to compensate for or you have to weigh that against the fact that A, you may not be able to hire a J programmer because they're rare, and B, they're uh, more importantly, you may not be able to hire a cheap programmer. You know, whereas with Python, you can hire really good programmers and you can hire cheap programmers that are, which are, I hope those are different things. Like I hope the good programmers know to charge for their time, and the cheap programmers. Well, I mean, sometimes cheap programmers are people who are very good that are taking advantage of geographical arbitrage, where a smaller amount of money is worth a whole lot more buying power, um, especially with like these these workers. But you know, anyway, in all these cases, there's a network effect. You can also hire, you know, somebody who might be very smart but has never done professional programming and just taught themselves Python. You're much less likely to find somebody uh, cheap to J or something. Um, and that's this is just a reality of the world. Companies want to hire the cheapest labor they can get, which probably is not always productive. But when I say companies, I'm making a very very big generalization, right? Most I know this is supposed to be about a course, but maybe I can wrap this around. You know, most commercial software development is just not that hard. You don't need really good programmers to do it. It helps, especially over the long run. Um, and or even maybe another way of saying that is you don't need a lot of discipline. You can write bad code, and you can get by on bad code for a long time, and many companies do. And then they eventually reach a point where the load on their system gets so high because of success, right? If you know if you're an entrepreneur, you're starting your company and you're just throwing any piece of code you can at the system. It doesn't matter if it's good code or not. It just matters if it works for now, because your company might not be there. There's always a short runway, and so it's always important. it's always important to deliver the features and get the revenue coming in, regardless of whether or not you're creating a huge amount of technical debt. Because if you're successful, if your idea takes off, you can afford to do it right. You can afford to come in and that's fraught adventure or whatever. Like that's a proposition. Like you're there's this idea of the second system syndrome. When you bring people in and they see, oh, this is your here's your $10 billion company running on an Excel spreadsheet, and they're like, oh, this is terrible. I'm gonna rewrite it, and but then it's like, well, I'm gonna rewrite it from scratch using all the greatest and best practices and all this stuff, and it takes a long time to do that. So you got to be able to one skill that's important to have is developers is to be able to cope with legacy code, even if it's your own legacy code months from now. But the point is that sometimes either because it's being written by people that are not good, do not know their craft yet, or because it is being written by people who are in a hurry, or it's being written by people who are very smart and just don't yet understand the problem. So it's exploratory code, prototype, that kind of thing. But all these cases you can wind up in a situation where you have this massive code, and now you have to go in and deal with it and refactor and clean it up and fix it. So how you do that is there's another essay I read a long time ago. I think it was by Joel Spolsky. I think it's called "One Thing You Should Never Do." I'm actually reading this in Firefox, and I think he was responding to "One Thing You Should Never Do." Go on software. He was responding to Mozilla. You should never do part 1. Yeah, this is like also from 2000. Part of that. Yeah, Netscape 6. So this was the browser wars. And wrote this. Yeah. They did it by making the single worst strategic mistake any software company can make. They decided to rewrite the code from scratch. I think he was right. I don't always agree with everything Joel has to say, but he was absolutely right about that. And it, good things came out of it many years later. But 20 years later, I'm using Firefox, but hardly anyone else is. This is dark energy. It's rewriting code from scratch is a dangerous proposition. And so part of another part of the network effect thing is that the more Python developers there are, the more PHP developers there are, the more Java developers there are, the more code there is that becomes open source and that you can adopt, and then you can say, okay, well, I would love to do this in J or Q or Quibble or whatever new any new language that you come across. But there's this awesome library that does 90% of what I want already, and it's written in COBOL. COBOL, thanks, and all these ancient things they use. So today, not very many, not a lot of new systems are doing that, but there are still COBOL systems. There's still APL systems. There are people now learning APL for fun, and there probably are startups out there using APL. Probably not too many. I'm sure they exist. APL is probably the most commercially. I'd say probably K is probably the most. I don't think there's a lot of startups using K though. I think that if you're a startup today, you're going to use an open. So of those, of the array languages, J is probably the one to bet on. And another reason why I think J could have that nudge that takes it over the edge and I mean, reading this today, it seems ludicrous to say that you don't you if you're learning programming today and you know what Python is, this article will not make sense to you because you're not getting the context that Python was an obscure, crazy language, just like J is today. And it doesn't matter that J is older than Python, right? It's just all about the curve, the exponential curve of getting the word out, and in general, populations and communities tend to grow exponentially on the internet, right? Slowly over time, right? By accretion. Like some random dude on the internet starts making a channel on YouTube about J, right? And so now slowly people trickle in as the more videos come out. Somebody hits subscribe and probably has no intention of learning J, but now it's part of their worldview. And then as video after video after video comes out, maybe maybe someday say, oh, I'll try it. I'll try it for a project. Who knows? Or whatever. But the point is that just having a website out there allows you to slowly collect interested people over time. And eventually you give them a place to collect or to congregate. They will congregate. That I guess that was a whole long trying to get better at speaking off the cuff and also trying to stay on topic. So I'm not on topic right now. I'm talking about this for a programming course. So anyway, let's start again from the top then. I've been at this almost about 30 minutes. Okay, so well, first of all, let's bring up the programming course. Let me bring it up in another. Google Drive. In case there's something from work. A lot of people share stuff with me. I have weird pictures pop up. I have no idea what they are. Sorry, clicked on them, link or something. Anyway, so I think it was called I made this thing many years ago before I started. Back when I was in Texas. Code course out. Oh. People's names up here if they don't want to be, if they don't, without asking you. So this is what I wrote. I don't know how old this was. I don't even know how you see a date. Created on 2012. This was what 9 years ago. Modified 5, 6 years. Anyway, so yeah, so this was before I came to 10. And at the time I was working on I had previously run a small company around 2008. It crashed and burned along with the rest of the economy. It took me a long time to get back on my feet. So I also was I was running this basically support operation, tech support operation, single-handedly many years, dealing with undiagnosed ADHD. I always say I don't know that I believe that ADHD is a thing. That diagnosis is silly. The criteria. It's not like you can do some kind of genetic test for this. It's a very open-ended set of questions. Answer yes to 6 of these 10 questions, or whatever it is. 10 of these questions, and qualify for having. Kind of silly. Not really well defined at all. So I don't necessarily know that I believe that ADHD is even a thing, but I do believe benefits of ADHD medication because they changed life. I went from struggling to deal with this company. I basically I couldn't keep up with the growth of my own company. So it grew very slowly over 10 years, and then I found myself, oh, okay, um, some of my customers, oh, mostly bloggers, right? Blogging was big time, and you know what? I got to save money now because the economy is going to crap. So I'm gonna, I don't need to spend $5 a month, like easy cut. Um, I lost a lot of business just from that, and so I had to take another job, like side job at the time. I was never I was never financially successful. I was getting by, um, and so now I'm balancing job over here with my not a job, but like contract work with running my company and trying to do tech support and answer all these emails by myself, not hiring anybody, and so I was underfunded and not able to withstand a dip in sales, and so it paid the bills for a long time, and then it stopped, and then kind of a downward spiral. So and in addition to that, I didn't. It slowly creeped up on me that I just couldn't handle the chaos. I kept trying to solve things by automating, and no matter what I did, there was just more and more work to be done. And I think web hosting, or at least the kind of web hosting that was popular 20 years ago, was it was shared hosting where you have 15 people on one machine, 100 people on one machine, and they're all doing different things, and so you can't specialize. They all have their own requests. Someday Mac comes out with a new calendar program, and Apple comes out with a new calendar program, and got half your user base suddenly is asking you for, hey, can I do iCal, or can I get? They wanted WebDAV, an HTTP extension set up on account, and I'm like, I don't know how to do this, and you have to go learn, and like the things that are rare, and sudden things that are rare become more and more common as you add more as your company grows, and so I was being pulled in all these different directions, and I don't know. I spent a lot of time like thinking about how to make systems better, how to make companies, how to make a small business better, uh, because I was unmedicated, right? Because I had a mental limitation, right? And then as soon as as soon as I started taking, finally went to the doctor and I got medication for this thing. Oh, wait a minute, I guess my perspective changed. Like suddenly the constraint was lifted, and it's like I can deal with all this stuff now. I'm not under so much pressure. Everything I was thinking about still makes sense for a larger, for a larger batch of problems, a higher support load than what I had, but it's no longer urgent. And so I don't know. Somehow that's connected to this course, I guess. That's kind of the mindset I was in at the time, and that's what I was going through. And I took some time off, and I wanted to after, I was took time off from work. I moved back in with my parents for a little while, and I was actually stayed with them for like years. And I was spending time trying to make a thing, trying to take everything that I learned and try to make a product. I did not know how to make a product. I didn't know how to make how to take a product to a market, how to test that idea, and I was very much about trying to build this thing that was very ill defined, and I don't know. Um, it also, thing I wanted to build at the time, and still kind of want to build someday, has to do with attention management. It has to do with I noticed that sometimes it was very difficult for me to answer all my emails. Part of the problem was just, there were different reasons. Like if somebody brought, I didn't have a good ticketing system. I tried many ticketing systems. I could not. It wasn't the technology. It was it's the rules around the technology. It was like, how do you use it? How do you incorporate it into your behavior? And I think that's what was missing. How do you take advantage of this enabling technology, right? Just because the technology's there doesn't mean you're going to know how to use it. Um, Even if you are using it, just dumping everything into a ticketing system doesn't necessarily. It doesn't tell you what's important, how to spend your time, and that kind of thing. But I definitely had the idea that I wanted to. How would you say this? Like, so I guess the idea had something to do with. I noticed that if I'm playing a video game, I can easily play a video game for hours, right? And it's because there's all these things in a gaming system that engage your brain in certain ways that allow you to be more effective at doing things that are kind of boring, right? Things like people will sit there and grind at a fetch quest, quests where they're somebody a famous game developer whose name escapes me at the moment, that might have been one of the co-developers on Civilization, said that given the chance, players will optimize all the fun out of a game, meaning that like if you can sit there and beat the tiniest enemy over and over again for hours and hours and hours and build your character up to the point that now you can go take on the end boss, people will do that and skip, because that's what the game rewards them to do. They'll do it happily. And we know that's we I think the game development industry is a lot more savvy about this now. Like, we know that there are patterns that we use to make. I'm not really a game hobbyist, but like, we know that there are these patterns that can entice players to play for hours on end, waste their lives playing this, because we set it up, because the game developers can set it up to do this, and they're called like dark patterns. Yeah, dark patterns in game development. I don't know. Maybe that's wrong. I believe that's what they're called. And so I think there's a light side to that. Like if you put your own, if you could take those things that can, those mechanisms that can trick you into doing, that can trick your brain into doing pointless tasks that are not really inherently fun for hours and hours and hours. Why not use that same thing to gamify your own goals, right? And of course, that's something that people have done as well now. They're probably seeing brushing your teeth, get points for brushing your teeth. Um, and I think that's a big industry, a big untapped industry even now. Even though there are like 100 apps you can download phone that help you set your goals into a game-like environment. One thing that I saw that, or at least I felt at the time when I was working on this, was that really want to do that well, you need to get control of users, the screen. You need to take over the entire screen, because like I can't tell you how many times I would sit down, like be sitting there thinking, like in the shower or something, like, oh, I've got to go work on something, especially before I had medication. I would be like, oh, I really want to write this article, or I really want to write this piece of code, and I would go sit down on my computer to do that, and I would open the computer up, and there would be like 15 tabs open, and one of them would attract my attention, and I would just forget about the two. Um, it happens so many times, and what The way I explain that to myself now is that I think that human beings use their visual field to augment their working memory. And so there's only so many things you can keep in your head at your thoughts at one time. And so you have a tendency to, you write a note to yourself. So we just have a tendency to use our visual field to store as an extra register or two for, what we're working on. And so if you have notes, if I had notes of like what I wanted to talk about in front of me, I would probably be a lot more on topic. I don't. And so even within the course of this broadcast, right? I know what I want to talk about, but I keep getting distracted by what's on the screen, and then also by the last thing I just said, and I go off on a chain, right? So to compensate for that, I definitely one thing I wanted was to be able to have like full control of the screen. I wanted to have, it's kind of sad because not sad, but too much to take on, right? Because what I convinced myself I wanted was a completely new operating system that would allow me to, or at least a front end, a user interface that would kind of encompass everything that everything, every application that I worked on, right? So more than like a window manager, not just a window manager, but like, it would definitely have it would have those applications embedded into it, but then there would be somehow it would unify everything. And I can't really explain it because I never really managed to come up with a prototype. I came up with a lot of like drawings, and I'm not going to show right now, but like it just seemed like the bigger this vision got, the more it encompassed, and so I wound up with this idea of like, okay, I'm gonna reinvent the operating system. And of course, that was just hubris, right? It's just way beyond my skill at the time. But not I say my skill, but there was certainly a lot of stuff I had to go learn, and I spent a lot of time reading about parsers and operating systems. Filling it, I'm a self-taught programmer, and I like to think I'm pretty good. I don't know. Everyone thinks I've been told by other programmers I'm pretty good, right? People sign up and listen to me talk on my YouTube channel, so I must have something to say. But even so, like the vision I had is just not something that I could accomplish. And this is like also thinking 20 years ago that there wasn't Vue and React and Angular and all these things. It was very hard to make interfaces well, at least on the scale I wanted. The tools just weren't. Skills weren't. I don't know. I had a lot to learn, and then I didn't have money, and I got a job, and then I stopped. So when I signed the contract for 10, you signed the non-compete clause, and they had a thing which most companies do, and I hate that companies do this. I understand why companies do this. They say this thing where basically in most tech companies, if you go and write code that is related to company on your own time, the company owns that code. That's just a condition that like many tech companies ask. It's a condition of hiring in many tech companies. I didn't like it, but I signed a piece of paper. And on the other hand, one thing they said was, on the plus side, they give you a list of things like, okay, if there's something you want to exempt from this, write it down here. And so one of the things I wrote was this, that outline this idea of like whatever I'm going to build around this course, I would not, you know, um, so anyway, I got a lot of mixed feelings about that, and I feel like now that I believe I'm a valued employee, maybe I can renegotiate that if I ever wanted to. Um, but someday I really like where I'm working, so I'm not going to leave unless somebody offers me like a whole lot of money, or I decide to go start um, or whatever, I win the lottery. Not that I play the lottery, but stocks take um, and I can afford to retire. But aside from that, like I'm really happy with where I'm at, but I also have this desire to build something on this. So I was thinking about that, and this was a long story. I don't think any of this is usable. Let's talk about the course itself. So this is what I was thinking. I was going through this with this idea of building an operating system, and so I thought that would make a good course. There is a course and to Tetris, something like that out there, and to Tetris. And I think it's all around a book called really cool book, Elements of Computing Systems. I highly recommend. Really good book. Which it's all around this course of like starting with NAND and the chip side. How do you get to Tetris? How do you get to something that complicated? And so I kind of want to do something like that. Um, but also kind of take my own learnings and my own spin on it. And the other aspect of this, I talked a little bit about in my when I talked about my dream REPL. I talked about the idea of narrative programming, and this was the other aspect of that. So I guess my other model is Project Oberon. The man Niklaus Wirth, the man who invented Pascal, Pascal programming language, gone on to then went on to implement Modula, and he was a professor at ETH, the technical. I'm not sure. Sorry. Anyway, he's retired now, but he was teaching these courses on how to build computer systems. They built a computer from scratch, and they all these things, and so he's kind of condensed all his years of learning into this oberon over the past many years. Even rewriting some of his old books, rewriting them. I have it on my shelf. Yeah, he's got a classic book called Algorithms plus Data Structure. Algorithms plus Data Structures equals Programs, and that is now this. That book has been rewritten. It was about programming in Pascal or Modular. Classic book, but he's reworked that over the years into this system called Oberon. So it's a much simpler language, same basic compiler from that book. I think there was like one chapter at the end. It was a lot of like sorting algorithms, and at the end there was like one chapter on writing a compiler. And so yeah, compiler construction. This teaches you how this right here, which is really good. Teaches you how to build a compiler from scratch for a very simple language that is very much like Pascal and Oberon. Anyway, so this all builds up to this entire Oberon system. You can. I know there's a way to. I think you can actually play this online. Play it on. So this is what Oberon looks like. So this is a man who has done what I kind of told myself I wanted to do here, which is to create a full operating system that is understandable by everyone. The other I guess group or people that have done something along those lines, Smalltalk. I mean, there's a lot of people like I spend a lot of time like implementing, looking at these systems like color forth, amazing tool. Uh, Probably not a general purpose system. I mean, the author would disagree, but you know, I guess these are all these tend to be you make a sacrifice by using a small system like not going to you can't run Firefox on Oberon, right, as the operating system. It's not built like that. That's not what it's for. There would have to be a completely new web browser built for this. It doesn't have the concepts, POSIX, got files and processes, pipes, shell where you're piping data from. There's no standard input. Uh, it's a very different model of world. Like this is it. This is the operating system, and each one of these text is built into the operating system. The idea of text, the idea of hypertext, and so you can just type. The idea of modules and scripting is built into the operating system. And so, like, if you click on System Free there, and it's a very mouse driven. You need a 3-button mouse and use like buttons on the mouse, chord combinations. Right? Like press one button down, drag, and then press the other button in the middle, and then let go, and then like all those like do something. And you can do some very advanced editing and with mouse button. So your mouse becomes your primary mode, and then you type when you. But anyway, you can just type these names and you can click on them and you type the name of some code. If you type the name of the code, it becomes a hyperlink. That's just built in. You don't have to have software to do it. So it's almost like a wiki. And so it's an alien system, right? And I think that is very cool. And yet, like, okay, well now, how do you load JSON into this? How do you? Somebody said recently to me, I forget, on the array languages. One of the biggest obstacle to learning these new languages, like Python or whatever it is, the very first thing people want to do is they want to go hit a web service and download some JSON and do that. And it's like you have to have you have to start with what people want, and you have to make sure that they can be productive and do something in the world and not just in your closed garden. So I think this. I'm not saying you can't do any of that stuff. Like, for all I know, there's probably. If you look at the. I think these are actually all the files. Like it's very small. So like fonts and stuff. It's not TrueType fonts. It's like his own little font system. But it's like the code is so small. With the intent that you can build onto this, but this was intended to be very small and understandable by. So, finish the thought that somewhere in there. The other one is small talk each other. Weak, Pharaoh. Something that I really like is built on top of this. Glamorous. I think is completely different. They've taken small talk and if this is a small talk. It looks completely different. It acts completely different, but it's built on top. But you can use it for working with Python or JavaScript. The language workbench. This is an amazing piece that I would like to talk more about. this piece of software is probably the closest thing I've seen to the thing that I wanted. Anyway, so you got all these little systems that do bits and pieces of what I want, but one thing that I guess they all have in common is that they're all full screen applications that kind of reinvent the notion of how you work with it. And I think with the dawn of web apps and runtimes like Electron, which is Electron, I think actually came out of GitHub. Oh, I've got a spammer in my channel saying webcam HD girls here. Great. Well, you just go want to block this person. Anyway, so Electron is a way of making a cross-platform JavaScript, but they're all based on basically a web browser. So they took the components of Chrome and how you can use that as a runtime and build your own. Firefox itself had something called Tool Runner for a long time. Before they've kind of, it was the same kind of thing. It was like the Gecko runtime for Firefox. These things are new. These things did not exist 20 years ago when I set out to make this thing. I can't even believe it was 20. Not 20 years ago. It was more like 10 years ago when I set out to make it. The tools just weren't there, and now there's like, I'm not unique in having these kinds of ideas, but anyway, so I wanted to make a system like this, and one thing that is missing from all of these, in my mind, every piece of software has it. It's called the gestalt problem, or I call it the gestalt problem. The gestalt problem is you encounter a new piece of software, and it's like a finished thing. It's like, okay, so look at the code for oberon here, right? Like, oberon is probably the closest system I've seen to addressing this problem. And because so in Squeak and Smalltalk, you have access to every piece of code here, but it's so big, so huge that and so Pharaoh and Glamorous. Pharaoh was a fork of Squeak, and then Glamorous is a fork of Smalltalk of Pharaoh. Glamorous is a Glamorous and the Glamorous toolkit is running on top of Pharaoh, and then they've rewritten the front end, the graphical tool. Squeak and Pharaoh, or at least Squeak uses this notion called morphic, right? So you have a morph, and then a morph is just anything on the screen. So button, any window, and circle. Like every probably each letter is a letter in a string and it's a nice consistent system, and but hard to find like where does this start. If you want to understand it, hard to see like give me an axiom of the system, and then help me understand just that one piece. Now build up on it. I'm not saying it's you can't do this. I've not seen Squeak or Pharaoh or a Smalltalk system presented this ever. And even Oberon. So what Squeak provides instead is a browser, like an amazing tools for browsing the code. So even though you don't know what's going on, you may not have that understanding yet. You have this hypertext system, like browser, in the sense of like browser has a back button. It has the ability to click on something and open a new tab, a new like, browser in the sense of hypertext becomes the way of how you interact with the system. All of these there's like different kinds of browsers become the primary user interface, abstraction or component or whatever, metaphor, not just Windows. So Glamorous takes that to whole different way of doing things, right? It provides a couple of standard browsers at the top, but it's still that same concept, but they replaced all the UI widgets and tab. It's not like draggable windows anymore. Kind of neat. It has this kind of like paging system where as you click on things over here, this new page slides in over here. I should probably just pull it. I'll talk about it another. Like these panes appear as you drill down into things. So it gives some kind of context to instead of just a window popping up, something pops up over here, and then UI slides over to the right or left or get like a horizontal scroll bar. And so you drill down right, and then when you're done, it's really really neat. And one thing I like about it is it maintains your context. So in my system, I don't have a system, but in my mind, I have this idea of stacks, right? And I talked a little bit about that in got context preserved. Maybe I'll show it. I'm gonna have more of these rambling conversations. I've been talking for an hour now. I never got to my my thing. I'm just yeah. Maybe this is part of the problem of like why it took me, why I spent so much time working on different things and not really getting to the things of what I'm doing. It's I'm much more productive when I look at something small, focus only on that, and just heads down work on that thing, and then time it grows up. But I don't know, like every once in a while you got to stop and look at the top down, and sometimes a lot of junk on your mental desktop. You gotta sort through it. Yeah. So I don't know. So this is kind of like how I would start, right? I thought my thought was it doesn't matter what language you use. Let's build a computer. Let's build a virtual machine. So we start with some very basic stuff like imperative style programming. What are the basic things? To me, these are the four things you need: sequence, um, currency being I mean, I have a lot to say about each one of these things. Concurrency seems like like something that you would not need. Uh, but I guess my argument is that really want to do it right, then you need some model of simulating parallelism. I say concurrency is probably what parallelism is not important. It's nice to have, but not. So these are the kind of the four concepts, and I thought it would start with tangible virtual machine. You would actually see. You would actually see. It would be a very small virtual machine, not like say 256 bytes of RAM or something registered, and you'd actually be able to see all of them on the screen, like visually on the screen, and you would be able to put things in there. Fill the registers with instructions, right? And you visually see the execution of your code. And so that would be the B4 virtual machine. Recently, like on paternity leave. Okay. My intent is to, well, like once you get the virtual machine, it doesn't matter what it's implemented. So the J implementation reference. So that's the idea: is take whatever language you want. Here you have this virtual machine, and now let's talk about. Okay, this is now you have a machine on which you can run programs. So let's start from that abstraction. But my other intent, the kind of like aside from the course, is that the VM is something that can be plugged into something like Glamorous. So now you got the system written in Smalltalk, but you could have this thing running on top of it. You could run it on top of Firefox. Right? Now you have your tool set inside of whatever environment you. My video editing program, the OBS, the broadcasting, scriptable, as far as I know. I believe it's scriptable. I believe it has like a WebSocket interface, and then you can hit that WebSocket and make it do different. Like, I hate that. Okay, you every time you learn a new language, you have to every time you learn a new system, you've got like a whole new toolkit or whatever. I want to be able to write my tools once and take them with me wherever I go. So that's kind of the other idea around before. And then the other idea is that it's narrative, so that it would start with, okay, what is a virtual machine? Here's how you build a virtual machine. This is my virtual. I do like it, but this one's fine. So here's my virtual machine. And now let's build something on it. Build some virtual hardware, like, okay, a screen, console. So much of what I've done in JPrez and console mode programming, all about building. That's a dry run. Because I think once you have a terminal, you can make like lots of user interface components. You don't have to worry about graphics. You don't have to worry about fonts. Fixed with bitmap fonts is a great way to get. You can get really far with that. And so it would be nice to have that terminal support everywhere. So now you have the exact same REPL, you have the exact same scripting language, and then there would be a mechanism within the virtual machine to expose like high level things in the environment, like objects, and so it would not be like it would have a set of very low level operations and a set of high level operations. The low level operations are XOR, swap, manage your stack, push this register, things like that. And then the high level things are very, very high level instructions for like create a new list or create a new dictionary or populate. Basically, they would be the things you would need. They might not be instructions. They might be like talk to virtual hardware or whatever. But you would be able to do they would provide everything you need to do to go hit a web service and for HTTPS and fetch a pile of JSON and then do something with that JSON and then render it to CSV. So all of that would exist as like virtual hardware. That's this very high level system, and so plug this into DaVinci Resolve, video editing program. That happens to be scriptable in Python and Lua, and for example, like I make videos with JPrez with REPL. Why can't I just have why not just have DaVinci Resolve render the console for me on the screen, and then I never have to like record the screen or whatever. I could just be part of the timeline. Just know about that. But that can't happen unless it's hard to make that happen right now. But when you have a small virtual machine and you have all your code running on that virtual machine, like it's portable not just between operating systems, but potentially portable between software applications. And so now you've got something that runs atop any scriptable software application. Yeah, and maybe you get them all to communicate, and they all become kind of assimilated in org-like structure. I don't know. So one aspect of that is you want people to adopt this idea and to make more systems compatible with it. So in order to do that, you want to. I don't want to write every one of those myself. I want to leave a roadmap for how to build this system. Now you can have your own copy of this system on top of whatever you want to do, or you can do the bare minimum. Now you immediately inherit everything that I've done. The next person's done, and the next person's done. You have to leave a trail. You have to leave a trail for how to get there. So my only complaint about Oberon, for it goes, it 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 takes a top down view of the system. So he comes up, he starts with the whole idea, and then he works through like stepwise refinement to arrive at the system. Like I think that is a pedagogical, like it's a good thing that he does that, but it's a good thing for somebody who wants to learn about operating systems. And highly recommend Project Oberon if you're interested in like world building or system building, especially operating systems. Even if you don't intend to use it, you can read it and understand this. This goes all the way down to the hardware. Like, he builds in Verilog. He builds the source code for a RISC reduced instruction set computer, right? Then builds everything on top of it. But like, there's a couple of missing steps where like I don't know. It's not missing because he starts from the outside, whereas just it's not a complaint really. It's just like a stylistic difference. Like I really want to build this. I want this to be not just like here's an operating system. I want this to be the again, the nan to Tetris kind of. The phrase I'm going for is that book Principia, or the Principia Mathematica. Yeah, where Bertrand Russell and Arthur North Whitehead, they set out to rebuild all of mathematics from axioms, set theory, and it takes a long time to get to 1 + 1 = 2. But when you get there, I mean, I have not followed. I have a friend who's read through it, right? Very into logic and stuff. Yeah, he also does cake. Probably know who caking. He's the logic system. The notation has evolved over years, and so the notation they use is very different. Even to the point of like how they don't use like parentheses and stuff like that. They have some like notion. Different kinds of dots mean different things. It's just a very strange notation. Yeah, there's no secret to this. Even after talking about, I think he's done. Well, it would not surprise me at all if this is. I would expect it to be. He's got all this stuff on like logic, and I don't know what the but he actually implemented I seem to recall him implementing like a translation between Russell and Ed's notation. Anyway, we're going right around in this time. Expression. Could be it right here. No, that's not at all. Maybe he didn't. Anyway, it doesn't matter. Anyway, but he wrote this. Russell and Whitehead. You know, they start with the axioms of the system. So the the other aspect, if I were going to do this, I you know, I might not do it in one pass, but ideally it would start with the notion of a proof, and using a system like Lean, their improver. Lean is a programming language, also a theorem prover, and could work through up to. It actually doesn't start with like set theory. It starts with type theory. Not like it's a constructive logic. I believe, maybe I'm talking out of turn here. I believe this one is built on constructive logic, meaning it doesn't have law of the excluded middle, true or false, right? Just because you can't prove things by contradiction. I'm not sure if that's true or not. I think it's built on that, and then it has extensions for that kind of proof. If you the underlying type theory, I could be wrong about this. It's been a while since I believe that. Anyway, it's not built on set theory. You can build it's built on type theory, a programming language type theory, or like a type theory like a program, like a type theory from like Haskell. But I am not. I am vaguely aware of the differences between these things, but it's like minutia that I do not. I could not talk coherently about at the moment. But anyway, so it's a really cool thing, and like it's also a proof assistant. So as you're writing, you can use it to write like code if you want to, but you can also use it to write proofs about. You can use it to write assertions about your data structure, about your algorithm, prove those things, and likewise you can prove actual mathematical concepts. So it's like all of these. It's for both, like, you know, mathematics and programming. You can certainly write programs in a style that is very mathematical, and provides proof at every step of that what you're saying is true. That, you know, you can write a that allows you to say, okay, here's my specification in this formal language of what I believe the system should do. Now here's implementation of that system. Now I want to prove that this implementation actually. And this is one way of doing it. Another one I really like is well. No, I guess I don't want. ISAR is the language, one of the languages. And I really like it. ISAR very has this really nice system where you can write. So in many theorem provers, you don't really see the proof. You see a user interface that says, okay, you need to prove this, and then it's almost like a video game. Like it's not. I don't know how to describe it. In here, I have something about the theorem. Four color theorem. So somebody at Microsoft did did implementation of the four color theorem in calculus of construction. Also, very Honda is one of the founders of calculus of construction, constructive logic that doesn't. You can't prove something by contradiction. You have to prove it by actually constructing the calculus of construction. And lean is the lean and Koch have a very similar underlying logic. But again, I think lean extends it in whatever. They're similar, but not exactly the same. Anyway, but in here, it's like, so here are the proofs. Like that's a proof. And what it is it's you're telling the proof engine. It's not clear what it is. So you tell it that I don't know this logic, but like probably one of these, probably a name that whatever. In this language, this is a true statement. C valid, whatever this means, that's a true statement. Each one of these words would be defined somewhere else. So okay, I see this is almost the same, not quite. So I don't know what these things mean, but it seems like okay. So this, in order to prove this statement, giving all the definitions before, these are the steps you have to do in the proof engine, and it's just not readable. It's like they're instructions for a machine to solve your proof. What I really like about Isabelle is that when you look at the proofs, trying to find a internal guide. What is the name of that thing? Archive of formal words. So, okay, category theory for ZFC in higher order logic. So is foundation of Hello Frankel set theory with the axiom of choice. Higher order logic. So these two different foundations of mathematics. I'm not really sure what this means. So given higher order logic, which is the underlying proof, Isabelle is a proof system that has pluggable logic, so you can start with whatever. I think there's like one language called Pure. It's like, here's how you do rewriting in some formal language, and now here are the axioms of higher order logic, and here, which is very much like type theory. Here are the axioms of ZFC. I'll build up ZFC for HOL. HOL higher order logic is like the one that of the foundations. Higher order logic has got like most development. But anyway, so you look at the code. So I don't. Then category theory is this whole other approach to like the foundations. But if you actually look at the thing, you can so generates. You provide the Isabelle ISAR source code, hypertext. Really cool. But so here's a proof in ISAR. So I'm not going to pretend this is like easy to read either. Certainly not. But now so here you're saying lemma. So that here's the name of the thing, and here's, I'm not sure, Ian probably just needs context. Right, so now here's my assumption, so that alpha is an element of beta, and then you bet beta. I'm not sure what this means. I don't know. Is there some kind of predicate? Beta could be a type. I don't know what it is. But given these assumptions, then whatever this means, element of the V set of B, whatever. Sorry, beta. Maybe not element of. Element, the subscript. But all of these are defined, and then in the actual tool itself, you can. I don't know why they don't do it here, but you can actually click on that and take into the definition. And so you by inspecting, kind of like the browsing, like Smalltalk, you can learn what every one of these symbols mean. Go directly to the definition. The browsing is not quite as good as Smalltalk has, but it's usable. You can learn to read this, and then so this is kind of redundant. This would not be shown on the screen in the book. You don't know why you're doing this. This gives you context. So this is kind of redundant, but it's like, okay, so this is kind of related to this. So we're going to prove this using some rule. So the transitive property of, and so once we have that, then I don't know what interpret means. I'm not sure what that means, but each one of these things means something. Each one of these you can add a new key. I'm not familiar with this, but you've got this interpreter, this proof assistant, kind of like reading through your code, and as it goes through each line, you're giving it instructions. So here you're going to say, I want to prove this. So in the context of proving this, you're going to prove this. Now here's the proof for that. You get the QED, and then you proved it. And now, from the second assumption, show this, and then now we can. So you can give it instructions. These are like rewriting rules, and it can be very like tactical. So this would be called a tactical, meaning these things are coded as tactics or subroutines within the proof engine, and you invoke those tactics. It's like calling a function to get what you want. Like this is like a shell script or something. It's like a recording of all the commands you type, without the context of why you type. And in ISAR, you have the ability to start from that, but also put as many details and steps as you want in there. Most people do not. It's like a mathematician would skip over a lot of steps. But if you want, you can do something. Get up. If you want, you can go all the way to like high school algebra style, which is kind of what I'm leaning towards, at a logical point. Where I got to talk about islands, but you can go into very so very like step by step exponents. Like this is something I wrote in ISAR. Yes, I set this up as a chat. I'm gonna hide my. Yeah, so here you can see like the theory of exponents. I gave a new name, something that already existed. I want to say, okay, so first that multiplication is commutative, and so that a times b, if they're natural numbers, is equal to times a, and that was already established past, but I just wanted to give it a new. This is I'm just experimenting. There's no reason to do this. You just use this name. I gave it this little name for that fact. Now I gave this fact this name. So this says that a to the b power to the c power as integers now, not natural numbers, equal to a to the times c. Um, and that was already proven as well. Power z power name for that fact. exp. And so now this is what I wanted to prove. And so now you can show it calculation stuff. So I can a to the b to the c is equal to a to the c to the b. That follows from these two facts, right? This is true, then b to the c, and then a to the b. You can apply this rule in reverse, and so that's what it does. So a to the b, or a to the b to the c is equal to a to the b by this rule, and hence, have, hence, and thus. These are all like words that modify the proof state. Now this stands for this, so we're like continuing the chain of equals. So this is now equal to this. So then from that we can prove that this is equal to that. Because it's equal. These words here kind of like give you hints about like which. I don't remember. But they give you like hints that they do different things about which context, which facts, and they change which facts are being incorporated. But anyway, so that's my proof. It's a trivial thing, but the point is you can do this kind of calculation style. And when so lean, kind of a newcomer to this. Both of these are like research projects that are lean came out of Microsoft. It's very small, fast, and like Isabel, whatever. It's a nice system, and it doesn't. It's not quite as not quite as like. I'm not sure you can get quite this far, but you can get pretty far in lean writing code. Like there is a keyword called calc in lean that allows you to write like calculation style proofs like that. And you can do this. So my thought is that I want to do this in a notation that looks like J, right? Or an array length. That's kind of like the goal that I have like long term, is to be able to do this thing. And so I didn't know how to write a proof engine when I was doing this, and I really wanted to do that. I wanted to be able to not just build this, but give people a trail to follow. B, prove every step of the way. Make all of this formally verified. It means you need a proof language. You need all the steps to be. So I would. I had wanted at the time to. So Isabella is very, very extensible. You can write. You can place the syntax, the inner syntax. In these languages, you have outer language, which is kind of like the red and blue keywords here. But then you notice that the actual object language, the language in which the mathematics language is in quotes. And that's because this notation, this syntax, can be placed with whatever you want. So in theory, you could have J code or K code or BQN code in here, inside of this, inside of these quotes, and you could write proofs inside of those things. So now J does not have. First of all, almost all of these languages lack operator precedence. precedence always goes left to right. And in a proof language, you want something like this equal sign. You want this equal sign. You want all of this to be evaluated. You want all of this to be evaluated. Then you have two nodes, two expressions that are then paired by the equal sign. Whereas in J or EQN or whatever, all of this is going to be evaluated, and then now you'd have to put parentheses around this side if you want that evaluated. And that's so it's a minor thing, but like that you need this sort of like meta syntax, both for the proof, but also for the logical connection. So these are type annotations. J does not have have the note types, and I would say you can't. Very hard to write a proof about a general you can't write a sum of an array, right? Because the array might contain characters. You have to write sum of it. You have to write a proof about the sum of an array of ints. So like this proof would not be valid in J because A and B and C could be characters. They could be symbols, whatever. And power can, yeah, that's the power. But so this would be syntactically, or this would be valid in J if it weren't for the lack of parentheses here, and well, the fact that these could be so this symbol right here does not return a Boolean in J. This returns a you have the word hello equals hello symbol, or string hello equals string hello. You'll get 1 1 1 1 1 oh 5 ones, whereas if you dash colon match operator, meaning the comparison operator itself is. So I guess the point I'm saying that is that I guess that I set this up as kind of like in my head. This was an obstacle making this course, was that I really wanted to do it that way. Proofs. I'm not experienced with writing proofs. Oh, so I have started on making a proof engine. And then somewhere in here, neologic. So it's just the Neil is another array language I really like, much less popular. And starting to, I invited the people working on it to come to the array language, which probably would. But it's a really nice language. But one thing so here I am writing attempt to write start on a proof engine. Unify to do like unification of terms. You have variables in. When you have variables in your proof, you let A be an array, right? So unify A with any array that is on the other side of the equal sign. So I've written unification. This is a step in like a lot of pattern matching. And then I actually went so far as to encode the. This doesn't do anything, but I encoded all the axioms of F, which have the axiom of choice. I don't know why I bring the axiom. Maybe I just didn't have the. I don't know. They, like as I said, they don't do anything, but these were accurate. To my knowledge, these are accurate encodings of so this is like there's like some encoding I found on the internet in traditional logic, and then I went through and I was trying to like make so these were tests for my parser. So if you pasted this into the parser for all abx, then x is an element of A. If x being an element of A is equivalent to x being an element of B for all x. It's interesting that x is lowercase. Bug or whatever. Again, this doesn't do anything. It was just parsing it, right? Parsing this expression. So if for all x's, x being an element of A is equivalent to x being an element of B, then A is an equivalent to B. A is equal to B. If this is so they're very, very related concepts, but like different connectors, right? Slightly different. So this is defining what equality means, whereas this is defining this is an if and only if in the logic language, defining equality in ZFC language. This is a symbol of logic, symbol of ZFC, and even though they almost mean the same thing, they're in different like levels of the language. You have there's a lot of this like stuff you have to do if you want to do formal programming. And so then the idea is now if you parse this rule for all A, B, X, I don't know why that passes that. Unless lowercase means for all A, B, X. This is the abstract syntax tree that you would get out of the parser. So there's an implication, so implication between this concept and this concept. Here's the X is a member of A, X is a member of B, if and only if. So if and only if of two things, then that implies that A is so and then now when you're writing like if this is really a definition of A equals B, then this would be if and only either direction. You'd be able to substitute either direction. Really, you'd want this to be this one, but you want to arrange your axioms so that they're simplification rules. And so putting this if and only if here would allow you to go from A equals B to for all X element of A, X is an element of B, right? Whereas this rule only allows you to say, if you've proven this and if you've proven this, now you can derive this. It does not show the opposite thing. But the idea is that you would write the simplest axiom that you can write, and then probably you can prove this, probably prove the other direction from these axioms. So that's kind of like what a mathematician would try and think. But that also simplifies the work that the proof assistant has. So this is not a proof assistant. This is a start on a proof assistant that I started many years ago and written in Neal. I really like working in Neal. Neal is another array language. It has nice symbolic tools. It has pass quoting around, so you can quote like an expression and pass it to a function and my check for equality. Comments, breaking me. But yeah, so I made a start on this, and I have not yet. I just had a lot to learn, and I didn't know if I wanted to. I don't know. I really another thing I like about Neal is it was based on array theory. So array theory is like a formal series of like formal specification of arrays. Formal meaning written in formal language, and this is Neal. So if you look at the documentation of Neal, or at least in the past, there were actually proofs, documentation of like equivalencies and things. I don't know. Like it got close to what I wanted to see with Jay, and so I kind of started here. And life happened. But I feel like I might pick this up again, either in Neal or Jay um, or starting with some new language that is like languages, but also going through so a very small array language that would have the benefit of these proofs all the way from the ground up as well. So that's kind of what I know I've just been all over. That's really what I kind of the. I'm not sure somebody listening to this could really tie any of this back to what's on this document here. But that's kind of like how I see it, right? Like yeah, I want to do NAND to Tetris. At the end, you wind up with simple text editor and a NAND to text editor. So I don't know. Yeah, I think I need to go. I've been talking for way too long. I'm not sure I stayed on track here. I had a lot to massive brain dump. So I will. I think I'm going to wrap it up here, and maybe next time I'll try again and take a smaller piece of this and try and expand it out. I don't know if this was worth watching, but it's good to reactivate all this stuff. Watch it. Have you here? I'd love to know comments here on Reddit. I don't know. Stay tuned and more of this will time and visiting this and try and narrow it down to something I can actually point to and say, yeah, this is what I'm talking about. All right. So I'm done. So watching. See you again next time.